The nuclear equation. First we have to take this and write it in its shorthand symbolic form. So we're going to write zinc. The mass number is 71, and so we're going to place the mass number at the top. And then at the bottom we need the atomic number from the periodic table, which for zinc is atomic number 30. Because it is a beta decay, or it's a beta emission, we're going to draw an arrow, and we are going to emit or give off a beta particle, which is 0 over negative 1 e for electron. Now the question is, what particle do we have remaining afterwards? And so we say, well, 71 is the mass number on the left, so 0 plus 71 on the right equals 71. And we need a total of 30 for our atomic numbers, so here we'll say 31 minus 1 equals 30. Now I'll look up element number 31 on the periodic table, and that is Ga, or gallium. So I'll put Ga here, and that is the beta emission of a zinc 71 isotope. Now we're going to write the symbol for radium-226. We're going to put Ra. The mass number is 226, and we look up the atomic number on the periodic table. It is 88. This is going to be an alpha emission, so we're going to draw an arrow, and then we're going to write an alpha particle, which is a 4 over 2 helium, plus, and then we have to figure out mathematically what isotope remains. So 4 plus what will give me 226, and that's going to be 222. 222 plus 4 equals 226. Down here, this has to be 86, because 86 plus 2 equal this 88. So I look up what is 86 on the periodic table, and that's going to be Rn, or radon. Now we're going to write the symbol for iron with a mass number of 55, and then the atomic number of iron is 26. And this one is a beta capture, which means I'm adding a beta particle to my iron. And then the question is, what do we end up with after this beta capture occurs? 55 plus 0 equals 55. 26 minus 1 equals 25. And then I look up element 25 on the periodic table, and that is Mn, or manganese. Finally, we take boron, which has a mass number of 10 and an atomic number of 5. And it's going to go through a neutron capture and an alpha emission. So we're going to add a neutron, which is a 0 over 1 n. A 1 over 0 n. And then we're going to yield, and we're going to emit an alpha particle, so that's a 4 over 2 helium. And then the question is, what other particle is being left over from this process? So we have 10 plus 1 is 11, which means 4 plus whatever this is has to be 11. So this is going to be 7. And then here we have 5 plus 0, it's 5. So that means 2 plus 3 is 5, and that bottom number is my atomic number, which is lithium. So this is Li.